This is an AIPMT 2014 question from System of Particles. The problem is like this. A solid cylinder of mass, radius is given for you. Free to rotate about its horizontal axis. A massless string is wound around the cylinder with one end attached to the other end is hanging freely. Tension in the string required to produce an angular acceleration of 2 revolutions per second. What he is saying is, there is a solid cylinder whose mass is given for you as 50 kilogram. Radius is given as 0.5 meter. Free to rotate about its horizontal axis. This is the axis. A massless string is wound around the cylinder like this. It's wound around. And the other end is hanging freely like this. In this string, a tension will be developed as it is trying to rotate the string, right? Then, because of this cylinder is having some angular acceleration of 2 revolutions per second square. Alpha is given for you as, but be careful, angular acceleration unit is not revolution per second square, but radian per second square. I have to convert that. When you say one revolution, it turns an angle of 2 pi. This is coming from a formula omega equal to 2 pi n, where n is number of revolutions. He has given n for you. You have to multiply with 2 pi to convert that each revolution turns an angle 2 pi. So for 2 revolutions also the angle covered is 2 pi. Therefore it becomes radian per second square. That you have to get it, right? You have to understand it. Then what is the tension produced? So, there is a torque developed. Torque developed in the system could be equated to I alpha. That can be written as force into perpendicular distance. Here force is tension itself. Perpendicular distance is nothing but the radius of the cylinder. For a solid cylinder about its natural axis, moment of inertia is mr square by 2. So mr square by 2 into alpha equal to torque into perpendicular distance. That's the radius. Let's substitute the data. Mass is given as 50. Radius is 0.5 square by 2. Alpha is not 2. It shall be multiplied with 2 pi as I told you. Equal to tension into radius is again 0.5. Let us simplify this. 50. 0.5 means 1 by 2. That whole square is 1 by 4. There is another 1 by 2. 2 into 2 is 4 pi. Equal to tension into 0.5 means that is 1 by 2. 1 by 2 can be cancelled. 1 4 can be cancelled. So what is remaining is 50 into pi. So the tension generated is 50 into pi Newton. Pi is 3.14. So 50 into 3.14 is the answer for the problem. That will be obviously 157 Newton. That's how we have to solve the problem. So the most important aspect of solving this problem is equating the torque from the rotational dynamics I alpha to the basic definition of the torque as force into perpendicular distance. One more important thing is moment of inertia of a solid cylinder about its natural axis is mr square by 2. Once if you understand these two, solving this problem shall be a very easy task and you can get this answer quite quickly. Thank you for watching.